Hello everyone, it's lecture 14, Determinants and Linear System. So, determinants, when I say determinants, is different from matrices. Matrices is just an rectangular arrangement of real numbers, okay? But when I say determinants is different from matrices, okay? So, determinants are scalar values related to square matrices. Okay, so determinants here I can get its value. Okay, and it's here I have here a1, here I have here a1, here a2, b1, b2, and when looking at this determinant I can say that this determinant here will order 2, okay, arrange it with 2 rows and 2 columns, okay, and here I have 2 diagonals. Here I call it principal diagonal and this is secondary diagonal, okay. So here I have a1 into b2 is principal diagonal, okay, and here p1 a2 is a secondary diagonal, and here value of determinant equal to here product of principal diagonal minus product of elements in secondary diagonal. So here value of this determinant equal to, so here equal to a1 b2 minus here a2 b1, okay. Here some important notes in this calculation. When I determine the value of determinant, must notice that number of elements in each term in calculation, okay, must equal to here order of the determinant. Okay, so here I have here determinant of order 2. Okay, so here I have A1, I have B2, here I have A2, and here I have B1. Okay, and here all elements must included in calculation. Okay, so I have here A1, B2, A2, B1. Okay, again we have here determinant of determinant of order 3. So we have here A1, A2, A3, here B1, B2, B3, here C1, C2, C3. Okay, so here we have determinant of order 3. So we have here determinant of order 3. Okay, and here let's determine principal diagonals and secondary diagonals. So we have here the first one of principal diagonals, here second one, here third one, but we know for that each terms in calculation must include number of elements equal to the order of the determinant. So we have here P1, C2, so we must write here A3, okay, and here we have P3, A2, so we must write here C1, okay. So here principal diagonals, here A1, P2, C3, and here P1, C2, A3, here we have C1, A2, B3. Okay, again we have here this secondary diagonal, and here we have secondary diagonal, here we have last 1. Okay, we have here C1, P2, A3. We have here P2. We have here P1, A2. So we must have here C3. We have here C2, P3. So we must have here A1. Okay, so here secondary diagonals. Okay, here are C1, P2, A3, and here B1, A2, A3. Here we have A1, C2, B3. Okay, so here value of this value of this thermals of order 3 will equal to, here we have A1, B2, B3 plus B1, C2, A3 plus here C1, A2, B3 minus secondary diagonals C1, B2, A3 plus here we have B1, A2, C3 here plus A1, C2, B3. Okay, so here I can write this in this form: A1 and 2 here, B2, C3 minus B3, C2 here minus B1 and 2 here, A2, C3 minus here A3, C2 plus C1 and 2, A2, B3 minus here we have A3, B2. Okay, but here if we notice from this bracket, that G bracket, I can reform this calculation to be as that. So this determinants of order 3 can be equal to A1 here, determinants of order 2, and here I can write that A2 here, B2, C2, and here P3, C3 here minus P1 determinants of A2, C2, A3, C3 here plus C1 and 2. Here I have A2, B2, A3, B3. Okay, so I just rewrite this calculation in this form of this element, okay, multiplied by these determinants, and here I can call this determinant as a minor of element A1 and this minor of element P1, this minor of element C1. Okay, and here if we notice that I can recalculate this, okay, and start from here along second row. Here I calculate along first row. I can take A2, B2, C2 as a common here, okay, and also I can start to calculate value from third row, okay, and here about signal here of terms. Here I have positive, here negative, here I have positive, here must notice that signal of terms related to position of its element. Okay, so I can generalize that and write my sign as -1 power of I plus j, and here I is the row of element, j is the column of my element. Here I have a1 of row 1 and column 1, so here power is 2, here -1 power 2 equal to 1, here b1 in first row and second column, so here this power will be equal to 3, so here -1 power 3 equal to -1, here c1 of first row and third column, so this power will be equal to 4, so -1 power 4 equal to 1, okay, and here if we proceed this about element A2, so A2 in second row and first column, so this power of my sign will be equal to 3, so I have here negative, okay, and here positive, here negative, here I have positive, negative, here positive, and here positive, negative, positive, okay. Just another one. If I have another determinant of order 4, so I have here A1, A2, A3, A4. Here I have P1, P2, P3, P4. Here C1, C2, C3, C4. Here D1, D2, D3, D4. So I have here determinants of order 4, okay, and here to determine the value of this determinant easily, as we know before, we have here our signs. Here I have first row and the first column, so I have here positive, here negative, here positive, here negative, and here we have here second row and first column. So I have here negative, positive, negative, positive. Here I have positive, negative, positive, negative. Here negative, positive. Here negative, positive. Okay. So here we have a determinant of order 4. Okay. And value of this determinant will be equal to, here we have a1, okay, into x minor. So we have here b2, c2, d2, and here b3, c3, d3, b4, c4, d4, again minus b1 into x minor. So we have here a2, c2, d2, a3, c3, d3, a4, c4, d4, plus here we have c1 into x minor. So we have here a2, a2, b2, d2, here a3, c3, d3, a4, e4, d4, here minus d1 into here a2, okay, a2, b2, c2, a3, b3, c3, a4, b4, c4, okay, and this is the value of a determinant of order 4. And let's think together on these values of b1 here, c1 here, and d1 here. If the value of a1 equal to 1, the value of b1 equal to 0, the value of c1 equal to 0, the value of d1 equal to 0. So this determinant of here order 4 can be converted or dimensioned into a determinant of degree 3 with a equal to 1 here into x minor. So this minor of element a1 will be equal to this determinant. Okay, so let's just here clear. we have here 2 and move to properties of determinant. Here, the first theorem of properties of determinant is two rows or two columns are identical, then the value of determinant will be equal to this determinant of, here we have 2, 3, 6, here 4, -1, 5, and here we have 2, 3, 6. Here we have two columns are identical, then this determinant will be equal to 0. Okay, the second theorem here, if any row or column multiplied by m, then value of determinant will multiply by m. Okay, so if I have here this determinant, here we have 5 and 2, 1, 2, 3, and here -1, 9, 7. Here we have 13, here 8 and 2. Okay, this product will be equal to, I can multiply 5 by any row or any column, and the value of determinant is unchanged. Okay, so we have here 5, -5, and here 65. Okay, here we have 2, 9, 8, here 3, 7, 2. Okay, I can multiply 5 by any row, okay, or any column. Okay, again for the last theorem, which is important one, the last theorem says if elements of any row or column added to m times to corresponding elements of another row or column, the value of determinant is unchanged. Okay, so if I have here negative, negative 2, here 3, 2, here I have 5, -2, -4, 4, 2, and here 3, this equal to, here I can say this equal to -2, 3, 2. Here I can write that, here I can multiply the first column by, let's say, first column by 3, then add to second column. Okay, so here I have 5 minus 2 by 3. Here we have -2 plus 3 into 3, and here we have negative 4 here plus 2 into 3, and here we have 4, 2, 3. Here this equal to, again, equal to negative 2, 3, 2, and here we have negative 1, here we have 7, and here we have 2, 4, 2, 3. Okay, this determinant will equal to this determinant. Okay, so there are most important theorem of properties of determinants. Okay, and the most ever important one is third one. Okay, let's clear that and start with our example. Find the values of these determinants. Here, start with the first one. I have determinant of order 2. So simply this determinant will be equal to product of principal diagonal minus product of secondary diagonal. So I have here 2 into 6 here minus negative 1 into 5. So I have here 12 plus 5 equal to 17. Okay, move to next one. So I have here this equal to 17. Okay, move to next one. Here I have determinant of order 3. So the signs of this determinant are there. Okay, so we can go along with any row or any column to get the value of this determinant. We can go along with any row or any column. So here, let's go with third row. Okay, so here we have determinant of order 3 equal to here 3 into x minor. So we have here 3, 2, here negative 6, here 3, here minus minus 4. So we have here plus 4 into x minor. So we have here 1, 2, here we have 2, 3 plus negative 1. So we have here negative 1 into x minor. So we have here 1, 3, 2, negative 6. So let's calculate this. So we have here 3, and 2, 3, 3. Here we have plus 6 and 2. Here plus 4 and 2, 1 and 3 minus 2 and 2. Here we have minus 1 of negative 6 minus. Here we have 2 and 3. Okay, so here we have 9. Here 12. 3 minus 2. Here negative 6 minus 6. This will be equal to 71. Okay, and this is the value of this determinant. So we have here 71. Okay, and for the last one here, I have determinant of order 4. So signs of this determinant. Okay, as follow. We have here plus minus plus plus minus plus minus minus plus minus plus. Okay, so here just the value of this determinant can be obtained by this method. We can write here, go along with the first row. We can write here for 1 and 2 x minor of here 1 and 2 x minor of 8 2 5. Here negative 4 negative 1 negative 3. Here we have 5 3 3. Okay, and complete with the other elements of first row. Okay, but here we will go in nested calculation, which may get difficult to evaluate it, but here we can use this theorem. We can, as we said before, we can make this row, the first row has only this value 1, and these values will be 0. So I can use the minor of the element 1 equal to my determinant. Okay, so again, just we will use the theorem of multiply elements of row or column by number, okay, and add to the corresponding elements in another row or column. So here I can multiply the first column by negative 4, then add it to the second column. So we have here negative 4 and to column 1, then add to column 2. Here we can multiply the first column by negative 3, then add it to third column. So we have here negative 3 into first column, then plus column 3. Again, with this value of 1, we can multiply first column by -1, then add to fourth column. Okay, so this determinant can be equal to here we have here first column 1, 2, here 4, 2, okay, and here we have 4 minus 4, here we have 8 minus 2 and 2, 4, here we have negative, sorry, here we have negative 4 minus 4 and 2, 4, here we have 5 minus 2 and 2, 4, okay, again with third column we have here 3 minus 3, we have here 2 minus 2 and 2, 3 from the first column, we have here -1 minus 4 and 2, 3, we have here 3 minus 2 and 2, 3, okay, and for the last column, okay, we have here 1 minus 1, okay, we have here 5 minus 2, we have here negative 3 minus 4, we have here 3 minus 2, okay, so this will be equal to here first column 1, 2, 4, 2, second column will be equal to 0, here we have 0, here we have negative 20, and from here we have negative 3, here we have 0, here we have negative 4, here we have negative 13, here we have negative 3, and last column 0, 3, negative 7, and here we have 1. So here if I try to calculate the value of this determinant can be equal to here 1, the first element of the first row, okay, 1 and 2, here we have the minor of 1 equal to here 0, negative 4, here 3, here we have negative 20, negative 13, negative 7, here we have negative 3, negative 3, 1. I will multiply the element 1 and 2, it's minor. Okay, as we see. So here from this I convert this determinant into the determinant of order 3. Simply I can calculate the value of this determinant, which equal to here negative 101. Okay, so this determinant will be equal to negative 101 by using this theorem. Okay, we can just we can say this: we eliminate one column and one row of this determinant to obtain simple determinant and calculate its value, which equal to the value of the large one. Okay, I hope this clear, and move to another